Hi, Shourya. Welcome to Be Fearless podcast.
Hello.
Such a pleasure to have you here. Shourya is our principal software engineer at SquareX and responsible for building so many features. So I know that you've been in the industry for quite some time now and had exposure to so many different security stacks out there. So tell us what, or better phrased, how does a typical security stack look like today in an enterprise?
Nowadays, like most of the organizations have a SASE solution, which is typically like a secure web gateway. So whenever someone is browsing the internet or accessing some applications over the internet, all the traffic goes through that and helps filter based on the policies. And then they also have a EDR solution on the endpoint, which basically protects any kind of malwares for coming in from the device. So typically, most organizations keep these two things as their stack.
Okay. And what do you see today? Do you see nowadays that existing security stack is able to protect enterprises from the threats that coming out there in the wild?
So, these solutions have existed for quite some time now. But nowadays, I feel the attacks are becoming much more sophisticated, especially the client-side web attacks. And because of that, there is a huge gap right now, which I feel is missing for many organizations. Many organizations have started picking up on that already, and they're adding like a browser native security solution to their stack as well.
I'm curious to know, why would an organization want to add a solution that sits on the browser?
So there are multiple advantages of having something like that. So let me give you examples of like few things. So for example, let's say, there's a phishing page. Now, attackers have been using multiple ways to bypass very basic checks. Like they may they may buy an older domain so that the domain age or the reputation is good enough. Similarly, they can host it on like known cloud services so that the reputation itself is good. Now, once those basic barriers are crossed, what comes down is what the content of the page is. And many a times attackers simply add like a CAPTCHA check on the page. So unless someone completes the human CAPTCHA check, the login form itself will not appear. And hence any of the cloud-based solutions who basically try to scan these URLs will not be able to identify if it's like a phishing page.
Interesting.
And this is one of the gaps that I see right now with existing solutions who not run on the browser.
Okay.
And also, just to add further on these kind of attacks, so they don't really have much context about what's happening on the browser. For example, let's say, so recently we unveiled these attacks called Last Mile Reassembly Attacks at DEF CON this year. And so we showed like different ways through which, without having a visibility, it becomes very difficult for secure web gateways to actually identify malicious files or malicious websites. So a few examples could be like, if let's say the whole the file itself was, let's say, encrypted and sent over the network. Or like, let's say the page itself is having like a file split up into different parts, and all of them are loaded in the same tab as different network requests. Now, since they're only looking at information at a network level, they cannot really figure out all of these are coming from the same tab because they don't really have the concept of tabs and windows.
Well, it's very interesting. And when you said about the part, how a certain file can be split into different parts, is it something that you also talked about at DEF CON? I'm just really curious, where does this concept come from and how something like this can bypass existing security solutions?
Yeah, so if we talk about like secure web gateways in general, they only look at information at a network level. So whenever, let's say, you're downloading a file, they may first try to cache the file in the cloud itself, do a scanning, and then allow the file to go forward. They don't know this request is coming from which tab.
Okay.
So let's say from the same tab, if I'm trying to download a file, not by a normal method like just hitting a link, but I instead have on my server side multiple parts of that file.
Okay.
And all of those file paths are fetched using different network requests. So in this case, individually, one part itself won't be enough for secure web gateway to figure out it's malicious, because as a whole, it becomes malicious. Now on the client side, using any kind of client side scripting language like JavaScript, we can actually combine all these parts together and then trigger a file download. So this will completely bypass a lot of secure web gateways out there because they don't have the context about the tab or window.
And how does it look like for a typical user? Does it look any different when you try to download a file? Do you see a difference? Hey, this file might be more malicious, or are you even able to differentiate that this is something that is reconstructed and then constructed back again? Or how does it even look like?
So this attack is so seamless that the experience is literally the same. So a user just goes to the page, they click on a button, and the download happens. Now on the background, it might be fetching it from multiple URLs and then putting it all together. But to the end user, experience is same as if it was like a single request.
Very interesting. But then let's say this is one type of attack, but I'm sure that SASE solutions still able to detect that something is going on. I'm sure that they're able to see something that's happening, like a certain download is triggered. Can you tell more about this?
So if a download is happening directly from the URL, not through any kind of client-side scripting, then yes, they can of course identify that.
Okay.
But in this set of attacks, since all these requests are just coming in and the actual download is triggered on the client side, they don't have visibility about that.
Okay. So they just don't say anything, there is nothing going on.
Yeah.
Oh, wow. That's kind of scary if I'm a typical user.
Yes.
Yeah. And which kind of organizations do you see to be quite vulnerable to this kind of attacks? So
this can be actually extended to any industry.
Okay.
Whenever there's a file involved, which typically covers almost every industry.
Yeah.
And so just to extend this a little bit. So typically when secure web gateways fail, the next line of defense that most organizations have is an endpoint security solution.
Yeah.
Now with the endpoint security solution, if the file is let's say a known malicious file, when let's say the download is triggered and it's it reaches the device, then their EDR might be able to pick that up.
Yeah. Yeah.
But there are two problems with that. First is that they don't give you much visibility.
Okay.
Yeah. So there's this thing called as mark of the web, which is often present with files, and you can just tell this file came from this URL, and that's the max they can help you with. Okay. And whatever data that they show you is simply hey, the file was downloaded from this URL and it came from chrome.exe, for example, in a Windows environment. Now, Chrome itself is a browser, and within that, there can be multiple tabs, there can be multiple websites.
Yeah.
But they don't have any visibility of what's happening inside the browser.
I imagine it makes it quite difficult for a SOC team to identify where an attack came from and then just correlate anything happening. So if, let's say, with existing security stack, is there any way to have this visibility, or what should a CISO consider to have any sort of visibility when it comes to this kind of attacks?
Yeah. So like I mentioned, the max information that you can get is just the file came from the browser. And this was probably the URL from where it came from, if the mark of the web is there. But other than this, unless they're using a browser native solution, they will not be able to understand how the whole user journey was. And the only way is to literally call up that person and ask, hey, how did you download the file?
I mean, that would explain why you're part of SquareX team today.
Yes.
And help to build. So, okay, maybe just give a brief overview. From what I understood, that right now you have very little visibility into whatever is going on the browser unless you sit directly there. So maybe just give us a little bit understanding, because for a lot of teams out there, I think, hey, I have enough protection and I don't need anything else. I think you covered quite a few blind spots that the current solutions are missing.
Yeah.
Maybe just elaborate a little bit more on this.
Sure. So let's say, you go to google.com, you search for some term, then you clicked on a link, that link opened some other page, you read it through, then you clicked on another link.
Yeah.
Now this is like a whole user journey.
Okay.
Right?
Yeah.
And this is what typically happened when the user actually ended up downloading that file.
Okay.
But like I said, the max information you get with existing solution is just the final page from where you download the file.
Okay.
But if you want to know the whole user journey, like, from where you actually started it, what was the whole intention of the user? So if we have this information, it helps us make better policies for protecting this like next time. And that's where a browser native solution like SquareX can help, because we can create something called as an attack graph.
Okay.
So attack graph is a way to visualize how the user journey is. So let's say someone opened google.com, they searched for a term, they clicked on a link.
Yeah.
So the whole part is shown in form of a graph.
Interesting.
And what makes it more powerful is that it's not just like, one user journey. If let's say there is a common IOC or indicator of compromise, then in that case, it will also interconnect that and create something called as related attack graphs, which basically help you analyze if there's like a campaign happening against your organization.
Okay. So let's say if one attacker is targeting multiple users, is this something that you're able to see?
Absolutely. And even if the channel is different, let's say it is reaching out to some people on LinkedIn, if it is like, emailing someone on Google Workspace or some other platforms. So we can actually interrelate all of that and say like, hey, it's a common sender who is sending all this information, or if it's a common file, which was sent by these different vendors or different users.
Yeah.
So all this can be interrelated and shown in the related attacks graph.
If someone shared a job description to me, I ended up opening it and then it infected the whole system, I would feel so embarrassed to tell security manager at my organization that I was the reason why. And the reason why it happened is because I actually opened something like this.
Absolutely. That's why it's important to have the visibility. That at least organizations don't actually have to go and ask the person, because like you said, in some situations they might be too embarrassed to like share the details as well. Yeah. So talking about like job descriptions nowadays, like a lot of these things are shared over Office documents. And recently we did a bit of research on Office documents in general.
Okay.
And we found out that many of even the endpoint security solutions were not good enough in detecting like malicious macros and Office documents.
How come?
Yeah, I mean, it was a surprise for us as well. And that actually, made us realize that there's also a gap little bit there where we feel like, Office document is something which is quite common. And it's something that that can be actually addressed through a browser-based solution as well. So what we did was we built our own in-browser scanner for Office documents.
Okay.
So let's say, someone is going to a website, like you said, LinkedIn, and they try to download, let's say, a Word file or an Excel file.
Yeah.
And in that file, if there is, let's say, a malicious macro present, we are able to now do a scanning within the browser. And the best part is that this Office document won't be sent to any of our backend servers. The whole scanning is happening right on the browser.
Oh, wow, I didn't know it's even possible.
Yeah, so it's very privacy safe, especially for Office documents, which might contain like, anything which might be quite sensitive for you.
Wow, I think you just had exposure to so many attacks going on out there, and I'm sure there are even more. What would you say are the top 3 prevalent attacks that you see nowadays that you think existing solutions aren't able to solve?
Yeah. So I think the first one would be the very first example I gave earlier, which was, phishing pages being protected by a CAPTCHA. That's something like most of the organizations right now are not able to solve. Second, I think would be malicious QR codes.
Okay.
The reason is that attackers are now becoming, quite smart, and they understand like you have all these tools on your laptops, but mobile is probably one channel through which they can, convince you to do things which might not be something you might be willing to do on the laptop.
Yeah.
So what they do is that they, just send you a QR code and say, hey, scan this. And the moment you scan this, your whole flow goes to the mobile phone. And then it makes it very difficult for existing solutions to capture.
Okay, yeah, makes sense.
So if there is a browser native solution, it can literally understand which link this QR code is pointing to, and can basically blur that QR code out within the browser itself.
So the solution is able to understand that the link it goes to is malicious?
That's correct. And at the same time, it can also based on certain rules, it can also just blur the QR codes out, making sure like all the flow remains within the browser, and the flow of the user is not going back to the mobile phone.
Well, I think it's super useful.
So, just to mention, we actually sort of extended this feature recently by also pairing this up with our remote browser solution. Okay. So let's say, you have this QR code, which looks suspicious. Let's say, it's pointing to a link which has a very less domain age, for example.
Yeah.
Or it's a link which looks very similar to a brand name.
Yeah.
So what we'll do is that we will blur the QR code out, but we'll also allow the users an option to click on that link. And when they click on that, instead of opening that link within the browser, we spin up a remote cloud browser and allow the user to visit there.
So in a way that there isn't any risk to damage your local system?
Absolutely.
Okay, that's amazing. I think it's super useful. And I think the point that you brought up about using your mobile phones, I think a lot of organizations have this BYOD policy.
Yep.
And how do you go about protecting your enterprise when it comes to BYOD? I know that you can impose some controls when it comes to managed devices, but what do you do when it comes to unmanaged devices? Yeah,
so on unmanaged devices, private access has been a problem. And the way we solve it is that we ensure that whenever you're accessing your private apps, it's being accessed through the browser and only if the SquareX extension is installed there.
Okay.
So this can be done maybe we can just go ahead and be like a third-party MFA factor in your existing identity provider.
Wow.
And whenever, let's say, they complete their SSO flow, an MFA page will kick in. It will just check whether the SquareX extension is installed. It can do some posture checks as well. And basis that, it will only allow you to access the applications.
Okay, this sounds super useful. It reminds me of a VDI, but is it something like VDI?
Yeah, so I mean, this is more about how you're providing the access. But after that, how you are really accessing the application is something where VDI comes into play.
Okay.
So for that also, we allow you to access web applications which might be internally hosted on your network, only and only if you have the extension installed and if the policy is allowing you to do so. We also extend this to things like RDP, SSH, and we also have full-fledged desktop environments which you can access through the browser as well.
Well, I think it's super useful for organizations that have a lot of contractors working for them.
Absolutely.
Yeah, and I feel like it becomes a really huge problem when you have some of these people also being part of your organization, and you have to both to keep them protected and at the same time to manage this access.
Absolutely.
I think one of the most cliche questions are out there. It's related to AI, of course. So how do you think today existing DLP solutions are able to protect enterprises when it comes to AI? And do you think whatever is done out there today is sufficient?
Yeah, so I mean, we have been talking with a lot of organizations, and what they typically do is that they just block the website altogether. Now that comes with a bit of risk. Reason being that people might end up using other websites which might be way less secure.
Okay.
And there can be granular controls that can be built over existing Gen AI tools as well. So for example, you can block any kind of clipboard paste from happening. That's one of the ways of putting a granular policy on top of Gen AI websites.
Yeah.
So you're sort of convincing people to maybe use it for smaller tasks, just maybe ask a question or something.
Yeah.
But not really allowing you to put any sensitive data out there.
Okay.
Similarly, you can do these checks basis of what the clipboard content itself was. If let's say there's some PII data or something which is sensitive to the organization, these checks can also be put in place. So what I'm trying to say is that the need is to have much more granular policies rather than just blanket blocking the websites, because because they might just end up using things which might be allowed on the network and which might not be secure enough.
Yeah, I think today when it comes to organizational security stack, right, there are so many solutions there. And to some extent, I feel like enterprises try to feed in for other security solutions that rather than security solutions trying to be tailored to problems that certain enterprises are facing.
Yeah.
So I think whatever you explain here, I think it provides such a, tailored response to whatever problems enterprises might be having.
True.
I'm just very curious, how do you see this whole space evolving in the next year, 2 years? And how do you see cybersecurity evolving within enterprises?
So I feel like, in the next 12 to 18 months, all these existing SASE solutions will become outdated to detect all these web-based client-side attacks. And the need for browser-native solutions will just become a pure necessity in any kind of organization.
Thank you so much, Shourya, for sharing all your insights, explaining why browser has to be part of your existing security stack. And I look forward to catching up again.
Thank you.